How many clients did your multi-tenant IAM platform serve? So the platform served roughly about 12 enterprise clients in production with another 4 to 5 in onboarding at any time. These were PwC engagement clients, so I can't name them specifically under NDA agreements, but they were across financial services, healthcare, and federal advisory. The largest had around 3,000 internal users, and the smallest a few dozen. How many tenants total? Clients and tenants, the same thing. In our model, one client could have multiple tenants, typically one per engagement or per business unit. So 12 clients map to about 30 tenants in production. Tenants were the isolation boundary, clients were the contractual relationship. Who were the clients? Can you name them? I can't name specific clients due to NDA confidentiality agreements. I can speak to the patterns. Heavily regulated industries, mostly North American, with strict data residency requirements for two of them. How much traffic did the platform handle? At peak, it handled around 800 requests per second across all tenants. So, across 30 tenants, like each of the tenant having 30 requests per second. So, that would be around 800 to 900 requests per second with P99 latency targets of 1200 not 1200 but 200 millisecond end to end. Auth validation specifically was sub 10 millisecond P99 because we cached the JWKS and did signature only validation in the process. Walk me through the tech stack on this platform specifically. The auth service and the tenant aware middleware layer were Go. The legacy services we wrapped were a mix of Node.js and .NET. That's why I touched all three on my resume. The data layer was PostgreSQL 14 as the primary store with row level security, Redis for token caching and rate limiting. Everything ran on AWS, EKS for the Go and node services, RDS, Postgres, multi availability zone, Elastic Cache, Redis. CI/CD was GitHub Actions to ECR, Argo CD for Kubernetes deployment, observability was Datadog for APM, CloudWatch for infra metrics, and we shipped audit logs to S3 through Kinesis. Why Go for the auth service specifically? I could say three reasons. First, single static binary deploys cleanly into containers with no runtime dependencies. Second, the standard libraries, crypto and net HTTP packages are excellent for token validation work. We used crypto RSA directly. Third, Go routines made the per request middleware pipeline cheap. We could fan out tenant config lookups in parallel without a thread pool framework. Honestly, Node would have worked to Go one on operational simplicity. Was this on AWS or on prem? AWS, specifically US East 1 as primary, US West 2 for DR. Two of our regulated clients required data residency in specific regions, so we ran isolated EKS clusters per residency boundary. The control plane, admin APIs, audit log aggregation was global. The data plane was regional. What did you mean by separate namespace for each tenant? Three layers of namespacing. At the database layer, every tenant scope table had a tenant ID column with a Postgres row level security policy that filtered all queries by the current session's tenant context. At the application layer, goes context.context carried the tenant ID through the entire request. Every service call, every DB query, every log line had context.context from the Go. At the Kubernetes layer, our most sensitive client got a dedicated namespace with separate node pools and network policies. That was operational isolation, not just data. Now, walk me through how Postgres row level security works. Show me a policy. RLS is a Postgres feature where you attach policy expressions to tables, and Postgres enforces them on every query. The application cannot forget to filter. The flow, I would set a session variable at the start of every request with the tenant ID. Then RLS policies reference that variable. Looking on the name board, what to write: alter table, table name, enable row level security. Alter table, table name, force row level security. Then create policy, policy name on API underscore keys using tenant ID equal to current setting bracket of app dot tenant ID. Set local app.tenant id is equal to some tenant id. Two things to call out here: first, force row level security. Without it, the table owner bypasses RLS, which is a foot gun. We forced it on every table. Second, set local instead of set. Set local scopes the variable to the transaction. So when a connection returns to the pool, it does not leak the tenant ID to the next request. That bug would be catastrophic. So that we do not leak the tenant ID, we are using set local. What happens if the application forgets to set the tenant context? RLS treats current setting as null. The policy filter returns false for every row and the query returns 0 rows. We preferred fail closed, no data over fail open. We also added a startup check that ran a query without the setting and asserted it returned 0 rows in CI. Doesn't RLS, row level security, slow things down? It adds an and tenant ID equal to $1 to every query plan, which Postgres can't always push into the index efficiently. We made tenant ID the leading column on every multi-tenant index. So multi-tenant index is tenant ID created at is an index, tenant ID user ID is an index. With that, the planner did partition style pruning and the overhead was under 5%. Without it, RLS could double query time on large tables. Why not separate schemas or separate databases per tenant? We considered all three. Pool model with RLS, one for our scale. 30 tenants, 12 clients, mixed sizes. Bridge model schema per tenant was operationally heavier. Migrations would have run 30 times, and our smallest tenants did not justify that cost. Silo model, one database per tenant. We did use, but only for the two regulated tenants that required physical isolation. The cost difference was significant. Silo was roughly 10 times the infra spent per tenant. How did tenant context propagate through your services? Go's context was the carrier. The flow is: request hits the gateway with authorization bearer jot, which is JSON web token. An auth middleware validates the JWT signature, expiration, audience, issuer, and extract the tenant ID claim. Middleware calls ctx equal to context dot with value bracket context dot comma tenant key comma TID and passes the context down. 4. Every internal handler accepts ctx context as the first argument. Go convention. 5. The DB layer wraps the connection with a hook. Before any query, it reads TID from the context and runs set local app.tenant ID equal to $1. The HTTP client wrapper adds X tenant ID header to outbound calls so downstream services don't have to reparse the JWT. The logger middleware adds tenant ID to every structured log line. Same with metrics tag. Show me the middleware code. So what you need to have in your head is the Go code. It has func as a keyword, tenant middleware, and arguments JWKS provider function http dot handler. So basically, it's a Go code for the middleware code. It is very difficult to explain in audio. You basically have some functions like r.header.get authorization. You also have jwt.validate on the token string jwks expected issuer expected odd. Now, if the error is not nil, then you have invalid token. If the claims tenant ID is equal to null, then it means http.error should give missing tenant, something like that. Now, how did you extract tenant ID from the JWT? What was in the token? Custom claim called TID. Token shape was as following. So basically, you need to have a JSON, and it basically have ISS, which is the uh, internal URL, then sub, then odd, then expiry, IAT, JTI, TID, which is tenant ID, rules, and scope. RS-256 signed, the TID claim was set at token issuance. When a user logged in, we looked up their tenant membership and embedded it. We deliberately did not let clients pass tenant ID as a separate header or parameter. It had to come from a signed token, otherwise an attacker could forge cross-tenant requests. What about users who belong to multiple tenants? They got one token per active tenant session. The login flow asked them to pick a tenant if they had multiple memberships, and the resulting token was scoped to that one, to that particular session. Switching tenants required a new auth flow. We considered multi-tenant tokens with a tenant array but rejected it. The principle of least privilege won out, and audit logs were cleaner with one token per tenant scope. How did you cache the JWKS public keys? Two-layer cache. In process LRU in each Go pod with a 5-minute TTL that handle the hot path. Behind that, a Redis cache with a 1 hour TTL as a shade layer, so a cold part did not hammer the auth service on startup. Cache key was the KID from the JWT header. On a cache miss, we fetched the full JWKS document and populated keys by KID. Stale while revalidate semantics, we would serve a stale key while refreshing in the background so a JWKS endpoint outage did not bring down validation. How did you handle key rotation? Standard dual key window. The auth service published both old and new keys in the JWKS document for a rotation window. 24 hours in our case, longer than our max token lifetime of 1 hour plus cache TTL. New tokens were signed with the new key. Old tokens validated against the old key. After 24 hours, we removed that old key. Rotation was scheduled monthly plus on demand if a key was suspected compromised. You said 35% latency reduction. Walk me through how you measured it. Datadog APM was our source of truth. Before the change, P50 was around 180 milliseconds and P99 was 450 milliseconds for authenticated endpoints. After P50 dropped to about 115 millisecond and P99 to roughly 290 milliseconds. The 35% number is the P50 improvement. I should have been more careful saying average, since the P99 improvement was actually closer to 35% as well. But the distributions tell different stories. Most of the win came from two things. One, eliminating the synchronous call to the auth service on every request. JWT validation went from a 30 to 50 millisecond RPC to a sub millisecond in process operation, and Redis backed caching for tenant config, which had been hitting Postgres on every request. How did you confirm zero cross tenant data leakage? That's a strong claim. Two layers of confirmation. First, automated. We had integration tests that ran on every PR where tenant A would issue queries with their token and we would assert they could never see tenant B's data. We had about 40 of these covering the main entities. Second, observational. We ran a SIEM rule on our audit logs that flagged any query where the tenant ID of the data returned did not match the tenant ID in the request context. Over the 14 months I was on the project, that rule never fired in production. To be precise, zero detected events. I can't claim zero possible bugs ever existed. I can claim our detection layer never caught one. Was this your design or did someone else architect it and you implemented? The high level multi tenant strategy, pool versus silo, RLS as the isolation primitive, was a decision the architecture group made before I joined the project. I owned the implementation of the tenant context propagation in Go, the JWT validation library, the JWKS caching layer, and the migration of three of the legacy services into the new pattern. I led the design of the audit logging pipeline end to end. I did not personally own the Postgres schema design, that was a DBA led effort I collaborated on. How big was the team? Six engineers on the platform team plus two DBAs and a security engineer who reviewed our threat model. I was one of the two senior engineers. The others owned the legacy migration tooling while I owned the tenant awareness layer. We reported to a tech lead who owned the overall architecture. How did you handle a tenant being deleted? What's the data life cycle? Soft delete with deleted at column, async job, asynchronous job to hard delete after 30-day retention window, separate compliance tier where deletion was immediate, audit logs retained for 7 years per regulatory requirement. What's the worst bug you shipped on this platform? What's the worst bug you shipped on this platform? A connection pool bug where set local was set on a transaction but the framework was returning the connection to the pool before the transaction committed in some error paths, leaving the tenant ID set for the next request. Caught in staging by the integration tests. Caught in staging by the integration tests, never reached prod. Fix was wrapping the connection return in a reset app.tenant ID hook. How did you onboard a new tenant? Terraform module that created the tenant row, generated the signing keys through AWS KMS, set up the IAM rules, ran the per tenant migration, self service for our internal tooling team after we built it. Previously was a 3-week manual process. What would you do differently if you started over? Sharper separation between the tenant directory service and the token issuance service. We coupled them and regretted it later. They had different scaling profiles and different consistency requirements.